Hi guys, this is Miss Baker and we're working on page 104. How is distance and time is mapped? Distance time graphs. Okay. Distance time graph shows an object's position as a function of time. The x-axis, which is the belly button axis, is time. The y-axis, which is the elbow axis, is distance. Imagine a ball rolling along a table illuminated by a strobe light every second. You can plot the ball's position as a function of time. Okay. Sorry guys, went too fast on that one. Let's go back. Okay, so this ball is actually not 10 balls. This is one ball. Every second, the ball is, there's a picture of the ball taken. Okay, and this is how it will look over the 10 seconds. Now, imagine this is plotted on a graph. At 1 second it's here, at 2 seconds it's here, it's 3 seconds is here, 4, 5, 6, 7, 8, 9, 10. Okay, speed is relationship between distance and time. It is graphed using a line graph where time is x, distance is y, and the origin is home. Home is very important. Okay? Your only direction is forwards and back. Okay? So we are not looking at left, right. We're talking about forwards and backwards. That's it. All right. So the next thing we're going to look at is we are going to actually look at an object moving, and we are going to show you what the graph of an object moving would look like. So this is called home. This area right here is called home. And the object is moving away from home, and there is a dot each second. Okay? The x is the x is time, and the y is distance. So the object is moving away from home. We are plotting it every second. Okay. Now this object is moving very consistently away from home. Think about this like a remote control car moving away from home at a very consistent rate. This straight line right here tells us that that rate is consistent. Okay, so when you are reading time distance graphs, home is 0, 0. So if the line starts right here, that means it is starting from home. But if the line starts anywhere away from 0, 0, that means it is moving, it starts away from home. So on this graph, our object starts away from home. But on this graph, way down here, the object is starting from home. Okay, if you are moving away from home, or if you are moving away, the line goes upwards. Okay? If you are going towards home, the line goes downwards until you hit the 0 line. This is the 0 line, the purple line. If you go past home, it goes below the line. So what this graph is saying is the object is moving away from home. It slows down a little bit. It continues to move away from home. Slows down, stops. Flat line is stops. Then it starts moving very fast away from home. Then it suddenly turns around and starts going back towards home. It goes past home, it stops, and then it moves back towards home. So anytime this line crosses or comes anywhere near this bottom X line, that means that the object is at home. So the object starts at home, at this point it's at home, and at this point it's at home. If the speed of the line is constant, the line is straight. So between time 5 seconds and 8 seconds, never mind. If the line is straight, that means the speed is constant. So between A and B, the speed is constant. The object is moving, but it is moving at a constant rate. From B to C, it is at a constant rate. In these terms, it is stopped. Okay? The flat line means it's stopped. From C to D, it's going very fast. The steeper the line is, the faster it's moving. The shallower the line is, this is shallow, this is steep, and this is flat. So a shallow line means it's going slow, a flat line means it's stopped, and a steep line means it's going very fast. So slow, stopped, fast, stopped, fast. Okay? The start from home, it is moving slowly away from home, then it stops. Now remember, time continues to tick by, so that's why it continues right here. It suddenly starts moving very quickly, still going away from home, and then it stops. It turns around and goes back towards home, not as quickly as it did between C and D, but still moves very quickly back towards home. So the constant, the line, if the speed is constant, the line is straight. If it is fast, the angle of the line is steep. If it is slow, the angle of the line is shallow. If it is stopped, the angle of the line is flat. If the line curves, then the speed is changing. If the curve goes upwards, the speed is increasing. If the curve is going like this, flattening out, the speed is decreasing. The closer it is to a flat line, the closer it is to stopped. So, questions for you. There are 4 questions you have to ask yourself for every section of a graph. Number 1, where are you starting from? Your only answers are at home or away from home. Remember, at home would be at 0, 0. Away from home would be anything else where your y is something other than 0. What is the direction of motion? Is it away from home, moving upwards? Is it towards home, going down to the X line? Or is it past home, crossing the X home? How fast is the motion? If the line is straight, the object is moving at a constant speed. If the line is curved, the object is accelerating or slowing down. The angle of the line is steep, that means it's moving fast. Not so steep is medium, shallow is slow, and fast is stopped. If the line changes, go back to step 2. Okay, so let's look at the green line. Green line starts from home. Because it's moving upwards, that means it's moving away from home. The line is flat, so that means its speed is consistent. It is steep, so it is moving very quickly. The red one starts from home. It is moving upwards, which means it is moving away from home. It is a straight line, so the speed is steady. And it is not very steep, so it is not moving very fast. The line changes right here. This line flattens out, which this means the object is staying still. It is stopped. At this point, it is changing direction. It is moving downward, so that means it is going home. And it is at a reasonably steep angle, so it's going reasonably fast. Again, it's straight, so it is at a constant speed. And if it stops at this line right here, that means it's going home. The blue line, starting from home, it's going upwards, so that means it's moving away from home. And it's curved, which means it's curved upwards, which means it's getting faster. Let's look at the yellow line. The yellow line starts way up here. That means it is starting away from home. It is going downwards. It is going towards home. It is steep, so it is going fast. But as it comes down here, it is starting to slow down. It is still going towards home, but it is slowing down. And at this point, it is almost stopped. Okay, why are these graphs different? How is the motion different? So, both of these graphs, the object starts from home. This graph, both of them show that the object is moving away from home because the lines move upwards. But this graph has curves. This graph is straight. So this one, the second graph, is saying it is moving at a constant speed. The curvy graph shows you that it is moving and changing speeds. It's going fast and then slowing down, almost stopped. Here it's speeding up, slowing down a little bit, moving consistently, and then slowing down more. Okay, so look at this time distance graph. Think, describe what may have happened. Provide clear details on what direction and speed the person was walking. So this person is walking. So the first question is, where does he start? Does he start away from home or from home? So he is at home. Is he moving away from home or is he moving towards home? It's going upward, so he's moving away from home. Is this line straight or is it curvy? It's straight, so his speed is consistent. At this point, the line goes downwards, so he's going to move towards home. The line is straight, so his speed is consistent. His speed is the same speed as he was going away from home. At this point, he changes direction again. He's now moving away from home. He has sped up a little bit. You see how the line is steeper? At this point, he is stopped. Remember, time continues ticking by, so this is why this line goes flat. Okay? All right. Okay, so now we're going to do the activities. So this page number 3 on your interactive notebook 104, your challenge is to plot the data on the graphs by placing colored dots on the graph, then find which story from below matches up with the correct graph, and that's supposed to be cut, not cup, and paste the story onto the correct slide. When creating a distance time graph, there are a few things you must remember. If your y starts at 0, then you are starting from home. If it is at any other number, then it is starting away from home. The direction determines the direction of motion. If it's going upwards, it's moving away from home. If it goes downwards, it's moving towards home until it crosses the x-axis. If it crosses the x-axis, then it moves past home. If the angle of the line determines the speed. If the angle is sharp, it's moving fast. If it's shallow, it's moving slow. If it's flat, it's stopped. If the y is a negative number, you are going past home. Okay, so the first thing you're going to do is you are going to graph this data. Now, I've done the first graph for you. At 0, time is x, distance is y. So you are going to grab the little balls, and you are going to graph them, okay? And then you're going to, if you want to, put a line between them so you can kind of see the pattern of the graph. Then once you have graphed them all, you are going to go back to page 3, and you are going to find the story that matches your graph's motion. So let's look at this graph motion. So the first question is, did the object start from home or away from home? This one starts from home. Does he move towards home or away from home? This one is moving away from home. Is he moving consistently or inconsistently? He's moving consistently because the line is straight. Is this line steep? Now, you compare it to the other lines. So this line is very steep compared to the other lines. So he's moving very quickly. Then he stopped. And then he changes direction because the line's going downwards. He's going towards home, but he's going slower. So what you're going to do is you're going to go back here. You're going to find the story that matches. You're going to you're going to highlight the story, Control X, and then go here, click here, and you're going to Control V it. Now, I've already put the story on this one, okay? So you are going to continue that. Okay, so you can grab these dots and you can move these dots. I don't care what color dots you use. You can use all red ones. I don't care. I just put the rainbow on there so y'all can choose any color dot you want. If you want to use lots of red ones, just continue using red ones. Okay. Okay, now you're just going to have to use all of the dots. You can Control C, Control V to have all red dots if you want. I don't care. So you're going to first of all graph all of these with this data. Remember, the time is X, distance is Y. You're going to graph the data. You're going to figure out what's going on with the speeds, and then you're going to place your story there. Okay? Then, now on this one, you can make up, on this very last one, you're going to make up your own story. So you're going to type in your distances here. So what I would do was I would start with my story. I would figure out what kind of story I wanted to tell. I'd make up the story. Then based on the story, you're going to come up with distances. And then you're going to graph it. So start with your story, then do your distances, then graph. And remember, this is a one dimension. You're going forwards and you're going backwards, but that's it. Okay? When you're done with this, go back to your first page and please do your summaries. Okay? I hope you guys have fun with this. Have a good day.